So in order for us to look at how to go about solving these systems, we want to use eigenvalues. Then it is important for us to know what eigenvalues are, eigenvectors are, eigenspaces are, and how to go about evaluating them. These are things that you guys have done in linear algebra, I suppose. So make sure you remind yourselves of how to go about them. Xt is equal to C1 exponential lambda 1t n1 plus C2 exponential lambda 2t n2. This will be our general solution. So I want us to look at how to arrive at this point. I want us to see how do we arrive at this point, because this is the solution. You've been given this system here, and the general solution is given by this, where lambda 1 and lambda 2 are the eigenvalues, and this right here stands for the eigenvectors. This right here stands for the eigenvectors. Okay, right up until that point so that we do an example. Okay, here is our example 1. Solve the following initial value problem. Solve the following initial value problem. X bar is equal to 1, 2, 3, 2. X. So we have X bar here. This is X bar prime. Given the conditions, X of 0 is equal to 0 and -4. Now, in determining the solution, obviously, we are going to be looking for the eigenvectors and eigenvalues. We already know how the general solution should be. So first, determine the eigenvalues. Now, how do we go about getting the eigenvalues? Now, recall the formula for getting the eigenvalues. It was given by the determinant of A minus lambda I, equating this to 0. This is basically A minus lambda I modulus is equal to 0. What is our A? Our A is the main matrix, which is 1, 2, 3, 2. Okay, now to get the eigenvalues, I am going to have A minus lambda I. A minus lambda I modulus is equal to 0. This is 1, 2, 3, 2 into minus lambda. Identity matrix is 1, 0, 0, 1. The whole of this is equal to 0. Now let's evaluate. This is the same as 1 minus lambda for this position, 2 minus 0, 3 minus 0, and then 2 minus lambda. This is equal to 0. How do we evaluate this? These two lines mean determinant. So getting the determinant of a 2 by 2 matrix, you cross multiply this minus this. So this is 1 minus lambda, 2 minus lambda, minus 6 is equal to 0. Can you guys solve this to get the lambda? Solve this to get lambda 1 and lambda 2. Those will be the eigenvalues. Solve this to get lambda 1 and lambda 2 very fast, please. Anyone with the answer for lambdas? Anyone with the answer for the lambdas? Anyone with an answer? Page, we should be on the same page, guys. The answers for the lambdas, when you work this out, you will get 4 and minus 1. Now, after getting 4 and minus 1, the next step will be for us to evaluate and get the eigenvectors. So I want us to get the eigenvectors. For each of these eigenvalues, I want us to get an eigenvector. Okay, so we said lambda 1 is equal to minus 1. So can we get an eigenvector? So eigenvector, we're evaluating for the eigenvector. Now, how do we get the eigenvector? Now, our main matrix was our matrix A. Let me write it again here. Our A is 1, 2, 3, 2. Now, to get the eigenvectors, this is what we are going to take. We are going to take A minus lambda x is equal to 0. So let me write the lambda with the identity here. Now, when lambda is equal to minus 1, can you take A and subtract minus 1 from the identity? It's like what we are going to have is A is 1, 2, 3, 2, and then we have minus lambda, so minus 1, and then the identity matrix, which is 1, 0, 0, 1, and then all this multiplied by x. So we can have x1, x2, but in our case here, actually we used n. So let me use n. So we have here n1, n2. If you use x, is still okay. This is supposed to be equal to 0. So this is what we are solving to get the eigenvectors. And when lambda is equal to 4, we are going to do the same thing as this to get these values. Now, let me start with this one. 1 minus minus 1, that will give us a 2. 2 minus minus 0, that will give a 2. 3 minus minus 0, that will give a 3. 2 minus minus 1. Minus 1 will give a plus. So that will be a 3. Multiply this by n1, n2. This is equal to 0. Then let's open this up and solve. So this gives me 2n1 plus 2n2 is equal to 0. And the other equation is 3n1 plus 3n2 is equal to 0. Clearly, these equations are more or less similar because from this one, divide all through by 2. Then what will I have here? I'll have n1 is equal to minus n2. Divide all through by 3. Then what will I have here? I'll have n1 is equal to minus n2. So if I was to write the eigenvectors, then I will have, if I make n1, like I write here n1, then writing n1 and n2, like if one is negative, then the other one is positive. So if I have n1 in terms of n2 or n2 in terms of n1, then 1. Let's say, for example, n1 is 1. If n1 is 1, then inamaanisha n2 inaenda kuwa minus 1. This can also be 5 and minus 5, but all the time we are always writing it with respect to the most simplest numbers kabisa. So our eigenvectors for this particular eigenvalue is 1 and negative 1. And the eigenvectors are not unique. So even negative 1 and 1 can still serve for this particular question. I hope we are together up until that point. So to finish off this one, the eigenvectors here are negative 1 and 1. Are we together? You can type in the comment section. The eigenvectors are negative 1 and 1 because in the general solution, I wrote n somewhere. So those n are going to be very important for us to find them. Those are the eigenvectors. Yeah, we are together. Okay, it's good to hear. Then you can copy that very fast, and then we look for the eigenvectors for when lambda is equal to 4. The eigenvectors for when lambda is equal to 4. Nirudie hapo chini. So hapa chini, basically, tukikuja kufungua hii hapa, tumesema jinsi ya kupata eigenvectors ndio hii formula. So nimekuja nikaandika matrix yangu, nikakuja nikaandika lambda yangu kwa sasa ni -1. So nikakuja nikaandika -1. Hii ndio lambda yangu. Alafu hapa ni identity matrix nimeiandika. Alafu hii ni column vector. So if I come and open this up, y1 and -1 and not any other value. Because Mary Kamene, we are taking the simplest values kabisa. You can even have 5 and -5. Most of the time when you are working out in mathematics, you're always simplifying your values to the, let's say we say 5 and -5. This is still 1 and -1. You just factor out, toa 5 nje, utabaki na nini? So ideally, all the time tunataka kubaki na the simplest values kabisa without writing it in terms of a fraction. That's why we are going with the 1. Simplest value kabisa bila kuandika hii kitu kama fraction. I hope we are together, Mary. So now, tukikuja, I am opening this up. Kifungua hii ni 2n1 plus 2n2. Ndo hiyo is equal to 0. Na hii ya chini ni 3n1 plus 3n2 is equal to 0. So these are the what? These are what are helping us to be able to find the relationship between n1 and n2. Na nimesema ukidivide hapa kote na 2, unapata n1 is equal to minus n2. Hapo ukidivide chini na 3, unapata n1 is equal to minus n2 bado. So we can be able to write as -1 and 1 or 1 and -1. Both will still work. Both still make sense. Now, when lambda is equal to 4, I want to do the one for when lambda is equal to 4. So when lambda is equal to 4, now our matrix A, let me just write it again for reference sake, is 1, 2, 3, 4. And what are we evaluating? A minus lambda identity multiplied by matrix, the column vector, this is equal to 0. So we know how this goes. So I'll just take 1 minus 4. 1 minus 4 will give me what? Will give me -3. 2 minus 0 will give me 2. I hope we are together now. I'm not going the long way. 3 minus 0 will give me 3. And then finally, 4 minus 4 will give me 0. When lambda is equal to 4. I hope we are together, guys. Are we together?
No.
Ask a question before I continue.
No.
Sorry? Excuse me.
When lambda equals to when lambda equals to 4.
Yes.
A equals to 1, 2. Then is it 3, 2 ama 3, 4?
Come up again.
Yeah. Hapo umeweka arrow kwa 3.
Hapa.
Yeah, hapo. Hiyo ingine ni 4 ama ni 2? Hapo sasa.
Let me check. Swali ilikuwa 2. Swali ilikuwa 2. Yes. Swali ilikuwa 2. Thank you for that. Swali ilikuwa 2. So A ilikuwa 2. So 2 minus 4. 2 minus 4 ni nini?
Okay.
What is 2 minus 4, guys?
-2.
-2, correct. I hope we are together now. I hope we are together now, -2. So we have this here, and then we have, let's open this up. This is N1, N2. This is equal to 0. Okay, fine. Let's come and multiply. This will give me -3N1 plus 2N2 is equal to 0. And this other one, I don't even need to write it because it's like the opposite of the other one with respect to the signs. Can you see? When you negate this one, you get -3N1 plus, so you get whatever is up. So let's just use this first one. Are we together? So -3N1 is equal to -2N2. Sindio? The minus and the minus can cancel out. So we can have our N1 being equal to 2 over 3N2. Okay, so if we write, let N1 be 1, we can write, we can have, if let's say N1 is 1, then inamaanisha if N1 is equal to 2 over 3, okay, let's say N2 ni 1, then inamaanisha N1 itakuwa equals to 2 over 3. Let me write it this way, in terms of eigenvectors, the relationship ni kuje niandike hapa N2. N1 itakuwa nini? N1 iko equal to 2 over 3 ya N2. Toa N2 nje. I'm just looking for the relationship for these two. Nikitoa N2 nje kwa hizo vitu mbili, nitakuwa na nini? 2 over 3 na 1. But I'm really trying so that I don't write these things in terms of a fraction. So what will I do in order for me to remove the fraction side? Multiply by 3, multiply by 3 on up and down. So if I multiply by 3 up here, what do I get? 2. I multiply by 3 here, what do I get? 3. So this is my eigenvector. I've gotten rid of the fraction so that it gives me something simpler. This is my eigenvector. Now we are just about done, guys. Remember, tulisema general solution inaandikwa aje. If you remember how we express the general solution, let me write it here. We said that our general solution xt is given by C1 exponential lambda 1t n1 plus C2 exponential lambda 2t n2. So we have our lambda 1, we have 1 is 4 and the other one is -1, and then we have our n and n, because we have the eigenvector for when lambda is -1, and we have the eigenvector for when lambda is 4. Can you guys write for me the general solution of this one and tell me what your answer is, please? Write for me the general solution for this one. Oh, by the way, we don't have the constants. Just write in terms of C1, C2. Were we given initial conditions when we started? Yes, we were given initial conditions, meaning we can be able to even get the constants. Initial conditions zilikuwa zinasema aje? Ilikuwa inasema x bar of 0 is equal to 0 and -4. Rudia hapo kwa solution. Okay, are we together up until the eigenvector? Because nataka kurab ndo sasa niweze pia kuandikia solution. Are we together? I will repeat. But are we together till the point where we've gotten this eigenvector? Hii tumepata eigenvector yake na ile ingine pia tulipata eigenvector yake. I hope we are together. Yes, aya. Allow me then to continue. I open another page. Okay, so just so that I write, wakati wenye lambda ilikuwa -1 na wakati wenye lambda ilikuwa 4. Wakati lambda ilikuwa -1, tulipata eigenvalues ni nini na nini. Hapa tumepata 2, 3, if I'm not wrong. Na hapa tulipata, was it, what did we write? Just remind me.
1, -1.
Tulipata 1 and -1. Na tulisema general solution inapeanwa aje? Tulisema general solution inapeanwa as xt is equal to C1 exponential lambda 1t N1 plus C2 exponential lambda 2t of N2. That's how we said we get our general solution. So in our case here, our general solution will be given by xt is equal to C1. We still don't have the values for the constants, but we have the eigenvector and eigenvalue. Eigenvalue is -1, so -1t, and then the eigenvector for this is 1 and -1, plus C2 exponential 4t. The eigenvector for this is 2, 3. So far, this is what we have as our general solution. This is what we have as our general solution. Now we need to find the constants because we've been given the initial conditions. The conditions that we were given are, let me write them down. Tulikuwa tumeambiwa x bar of 0 is equal to 0 minus 4. Let's interpret this condition. X bar of t. X bar of 0 inamaanisha wakati t ni nini? Wakati t ni 0. Wakati t ni 0, hii kitu yote ni 0,4. So nikikuja kurewrite hii kitu hapa, x bar of t ni nini? 0 minus 4. Wakati gani? Wakati t ni 0. Eka 0 mahali penye kuna t. Nikieka 0 hapa, what is exponential 0? Exponential 0 is what? 1. Si ndio? Ongeeni na mimi. Exponential 0 ni nini? 1. So fungua hii. Hii itakuwa C1 minus C1. Plus, eka 0 hapa. Exponential 0 ni 1. Fungua hii hapa. Hii itakuwa 2C2. Alafu hapa itakuwa nini? 3C2. Now, if you are to solve this, you can clearly take the upper part, have this as an equation, and solve for me C1 and C2. C1 plus 2C2 equal to 0. C1 plus 2C2 is equal to 0. And then the other one is minus C1 plus 3C2 is equal to minus 4. Can you guys solve for me this to get the answer for C1 and C2? And then we bring it back here, so that now we have a solution without the constants. We bring it back here. This is our general solution. This is our answer. But now we want to get it without the constants. Solve for me C1, C2, and let me know what you get before the meeting ends.